Hello students, today we are going to see projectile motion. In projectile motion, a topic in two-dimensional motion or motion in a plane. Some different types of projectiles. Already we have seen projectile like this, that is a particle is projected at an angle theta, with an initial velocity u. So here we have taken like this is u cos theta, this is u sin theta. Throughout the motion, g will be acting in the downward direction. On the top of the projectile we have u cos theta. Okay, likewise this one we have seen. Okay, time of flight 2u sin theta by g, range u square sin square theta divided by u square sin 2 theta divided by g, and height, that is this height is nothing but u square sin square theta divided by 2g. So we have derived all these formulae from this projectile. One more thing we have studied, like y is equal to x tan theta minus half g x square divided by u square cos square theta. Okay, equation of the trajectory. Okay, one more equation was there. Y is equal to x tan theta into 1 minus x divided by range. Okay, so all these things we have seen. Okay, then regarding the energy, change in velocity, change in momentum, all those things we have seen. Suppose here kinetic energy initial. Okay, here kinetic energy initial, potential energy is 0 here, total energy is nothing but initial kinetic energy, which can be written like a half mu square. And at the topmost point we have already seen kinetic energy at a maximum height is nothing but this one, ki cos square theta. Potential energy at a maximum height is nothing but kinetic energy ki, that is initial kinetic energy, sin square theta. This is same as total energy. So we can write in this way also, total energy cos square theta or total energy sin square theta, or even in this way also we can write half mu square, that is initial velocity square, cos square theta, or half mu square sin square theta. Okay, so all these things we have done detailed analysis of projectile, and we have done lot of problems also. But projectile means this need not be the only projectile. Projectile can be of different type. So we will see all that, and we will see how to approach the problems related to it. Okay, so this was a quick recap. Okay, now different types of projectile. Okay, suppose this is a tower, okay, from this a particle is projected like this. Okay, now this is the ground. Okay, particle is projected like this. So if we draw a straight line here, we can write theta, and this is projected with an initial velocity u. So how we have approached for that projectile, in the same way we can approach for this also. The same approach we can do here also, right? So suppose if we need to find time of flight, okay, total time the projectile in air. If we want, we can resolve this into what? U cos theta, and this is U sin theta, correct or what? U cos theta and U sin theta. In this way we can resolve this. Now whatever we want we can find out. Suppose if this is the height of the tower, this is h, and this is the range r, that is horizontal displacement. Okay, now obviously G is acting in the downward direction. What we want to find? Suppose if we need to find range, what can we do? Range is actually what? This is actually horizontal displacement. So here range is equal to horizontal velocity into time. Because horizontal velocity will not change. No force is acting. If force is acting, things will be different. No force is acting, so Vx into T. So what is Vx? Vx is nothing but U cos theta into time is what? Total time taken to fall down. So using this you can find range. Suppose, so this is nothing but Vx into T. Fine. If we need to find the height of the tower, okay, so here what we can use, since G is acting here, acceleration is there, we will have to use S is equal to ut plus half at square formula. S is equal to ut plus half at square formula we will have to use. So here what is the initial vertical velocity? U sin theta. So U sin theta into how much time taken? T minus half gt square. Likewise we can find the height of the tower, the range. Okay, suppose if range is given, we can find out this time of flight. If this height of the tower is given, time of flight can be found out. Okay, so this way we can approach this. Whatever we want, we can find out based on the question. Okay, please note it down. Clear? Right. Now suppose same way another case is this is going straight and falling like this. This is falling straight and falling like this, not at an angle. So this is height and this is range. Total time the particle in air can be taken as capital T. So how to find range here? Suppose this has an initial velocity u. Since it is not at an angle, we cannot have cos theta, sin theta, we need not resolve. Simply that is u. So suppose if we need to find this range, this is simply we can write u into t. Same way h is equal to u. What is ut? H is equal to actually uy into t minus half gt square. Since we are measuring downwards, this should be minus h. Even in the previous case also, minus we will have to put. Okay, just that you already know. Already we have covered similar cases. Okay, likewise we can write. And here this is pakka horizontal velocity. There is no initial velocity in the downward direction. So minus h is equal to, this will become what? 0. So minus minus will get cancelled. Half gt square we can write. Like this we can find out various values. Clear? Okay, one more possibility I shall share. Suppose if this is a tower, a particle is projected like this, that is at an angle theta. So this is range r, this is height h. Total time taken for reaching the ground is capital T. Then this is the case. Okay, so what is initial velocity is u at an angle theta. Okay, so we will have to resolve here because this is at an angle theta. So this is going to be u cos theta, and this is what, u sin theta. So if we need to find r is equal to what, velocity in the x direction into time t. So r is equal to u cos theta into t. And suppose if we need to find h we will measure in the downward direction, minus g is there in the downward direction. This is equal to minus u sin theta. Sin theta is in the downward direction, u sin theta minus half g t square. Anyway, all the signs will get cancelled off. H is equal to ut. So t is here, ut, u sin theta into t plus half gt square. So likewise we can approach. Now we will do some problems. So one problem. Okay, so the height of this tower is 20 meter. It is projected with a velocity 5 meter per second. Okay, and it will reach the ground like this. Okay, this is the situation. Now what we need to find, time taken to reach ground. How to find out? Time taken to reach the ground. Okay, so do yourself and check the answer here. Okay, fine. So here what we will do, the available data is height is here. Okay, height is here. So how much time the particle will take to cover the vertical distance, the same time the particle will take to cover the horizontal distance also. So it will come like this. How much time it takes, same distance for horizontal and vertical. So let us consider h is equal to ut plus half at square formula we will use. So h is equal to, suppose if it is minus 20, this is equal to 0, no vertical component here, vertical component is equal to what, 0. So and this is equal to minus half into g, let us consider minus 10 into t square. Okay, this is what, so 0 0 cancelled off, and t square is equal to what, 4, and t is equal to what, 2 seconds. So time taken to reach the ground is what, 2 seconds. Okay, so this is one question. What is the horizontal range? What is the horizontal range? Okay, can you do that also? What is the horizontal range? Horizontal range is how much? Vx into t. Already we have found 2. Vx is nothing but 5. 5 into 2 is equal to 10 meters. So this much is the distance covered. Okay, is it clear? Another possible question is, find the velocity with which it hits the ground. That is, what is the velocity at this point? Find the velocity with which it hits the ground. How to find it? How to find the velocity? So to find the velocity, we will have to find Vx also and Vy also we need to find. What will be Vx? There is no force, no acceleration in the horizontal direction. So Vx is going to be what? 5 meter per second itself. What about Vy? We will do V is equal to U plus AT formula we will apply. Vy is equal to minus, okay, U is what? 0 minus GT. So Vy is equal to GT 10 into how much is the time? 2. So this is going to be 20 meter per second. So V is going to be how much? 5I minus 20J. Because when it comes like this, one component will be in this direction, another component will be in this direction. Correct or what? So 5I minus 20J. Suppose if we need to find the magnitude, this is going to be 5 square plus 20 square root of 425 meter per second. This is the answer for this question. Okay, clear? So here this sign we need not give. We do not know, just leave it to the answer. Simply we can write 0 minus GT, let it be anything. So here minus, if you put minus will come, so that directly we need not, we can directly think. Anyway, it makes sense, we need not worry about it. Hope you understood how to solve these kind of problems. Okay, now suppose if it is coming like this, what angle it makes? Suppose I can take angle with respect to vertical, or I can take angle with respect to horizontal. Okay, so suppose what angle it makes with the horizontal, such a question is asked. What is this theta? So how to find this theta? Okay, I will draw clearly. If it is like this, okay, so if here this is theta, this is Vx, this is Vy. So if you need to find the angle with respect to vertical, what we need to do, this Vx we can replace here. Sorry, this Vy we can replace here, Vy. So if this is theta, tan theta is equal to opposite side Vy divided by Vx. Okay, so theta is equal to tan inverse of Vy by Vx. What is Vy? Vy is minus 20 minus 20 divided by 5. So likewise we can find the angle also. Is it clear? We'll take another problem, another projectile, but in the same way we can do this also. Okay, this is a tower, this is projected like this. Okay, this is at an angle 30 degree, u is equal to 30 meter per second. This height can be considered as 20 meter. First question is time taken to reach ground. Time taken to reach ground. Okay, so can you solve this? Solve yourself and then verify the answer here. So this is available. This how much time taken for vertical coverage, same distance, same time it will take for horizontal coverage also. So vertical coverage is 20. So let us consider H is equal to UT plus half AT square formula will be using. G will be acting in this direction. So this is just like minus 20 and this is equal to U sine theta. So 30 sine 30 into T. Okay, this T I missed. Minus half into 10 into T square. Okay, now this is fine. Okay, so this we will cancel. So minus 2 is equal to sine 30 is 1 by 2. So 3 by 2 T minus T square by 2. So we will bring it this side. This will become minus 4 is equal to 3T minus T square. So we are getting like we will bring it to this side. T square minus 3T minus 4 is equal to 0. So we are getting an expression like this. So how to solve this? Solve this quadratic equation so that we will be getting an answer. So suppose 2 into this is nothing but 1 into 4. If we do 1 into 4, 1 into minus 4 is this one. Okay, so T plus 1 into T minus 4 if we do, this is equal to 0. Okay, so we will be getting T is equal to 4 seconds. This is correct answer. T is equal to minus 1 we need not accept. Okay, is it correct? Okay, so here as we did in the previous problem, if you want we can find this horizontal range. Okay, horizontal range is how much? Okay, suppose if we need to find horizontal range, okay, R is equal to Ux into T. Ux is nothing but U cos theta. So 30 into cos 30 into time 4. So this is actually root 3 by 2. So 15 root 3 into 4 will be the answer. So this is going to be 60 root 3 meters. 60 root 3 meters. This is the horizontal range. Clear? So in the same question, if you want, we can find the velocity before hitting the ground. That also we can find. Okay, so time taken T is equal to 4 seconds and range is how much? 60 root 3 meters, correct or what? 60 root 3 meters. This is the range we have calculated. Now what is the velocity before hitting the ground, if that question is asked? So for that we need to find Vx and we need to find Vy. Vx is how much? Same thing, U cos theta. U cos theta, that is not going to change. So U cos theta is 30 into cos 30. So 15 root 3 meter per second. This is Vx. What about Vy? Vy is equal to Uy plus ay into t. Okay, so Vy is what? Vy is equal to u sin theta minus gt. So Vy is equal to u30 into sin 30 minus 10 into 4. So Vy is equal to, this is 15 minus 40 will be getting 25 meter per second. Vx and Vy we got. So V is equal to 15 root 3I minus 25j in vector form. Okay, so this is the velocity. If we need, we can find the magnitude, we can find the theta, everything can be found. Clear? Shall we do another question? Note it down. Okay students, this is our next question. So here a projectile is projected at a 30 meter per second with an angle 30 degree. This range is given 30 root 3 meter. We need to find the height of the tower. We need to find the height of the tower. Okay, so please do yourself. Okay, solve this question yourself, then verify the answer. Okay, so pause the screen and do yourself. Okay, in order to find height, I am going to use this equation. S is equal to ut plus half at square. So here sy which we need to find, so uy, ay, everything y we need. Okay, so this is going to be u cos 30 and this is going to be u sin 30, u cos 30 and u sin 30. We need to find this height. So height is equal to u sin 30 is negative direction, so u sin 30 into t minus half ay is in negative direction, so I have used minus here and t square. So here I don't have the value for t, so that we can find using horizontal direction and horizontal velocity. So horizontal displacement range is 30 root 3 and so we can say time t is equal to what? X by Vx. So this is what is Vx? Vx is u cos 30 or 30 into root 3 by 2 will be getting 15 root 3. 15 root 3. So x is equal to 30 root 3, Vx is equal to 15 root 3. This will be cancelled off. We will be getting 2 seconds. Now we'll substitute here. This is equal to minus 30 into 1 by 2 into 2 minus half into 10 into 2 square. So this 2 will be cancelled off. Minus 30, this 2, this will be cancelled off. Minus 20. So height of the tower is nothing but minus 50 meters. Minus 50 meters. Height of the tower is minus 50 meters. Okay, we have taken the sign like that, so we got minus, and height of the tower is the displacement from the initial point. So that is why we are considering that as negative. Okay, a fighter jet is flying horizontally at 200 meter per second. Okay, a fighter jet is flying at 200 meter per second. Okay, a fighter jet is flying horizontally at 200 meter per second at a height of 1 kilometer from the ground. So this height is 1 kilometer. It wants to destroy an enemy base camp. It wants to bomb an enemy base camp. How far from the camp it should drop the bomb? How far from the camp it should drop the bomb? So it is, they are asking like a horizontal distance, from how from what distance, okay, it should drop the bomb so that it will be hitting the target correctly. Okay, so pause the screen and do yourself, then check the answer. Okay, done. So how much time this a bomb will take to cover this vertical distance? That much time it will take to cover some horizontal distance. So what we will do, we will try to find the time for covering this 1 kilometer. So G is acting in this direction, Vy is 0. Okay, this much is there. Now we will try to find the time taken to cover this horizontal distance, which is nothing but y divided by, G is there, so S is equal to ut plus half at square formula we will use. Okay, so this is equal to minus 1 kilometer means minus 1000 is equal to, this is actually 0, uy is equal to 0, this is actually Vx, this one. So this is equal to minus half into 10 into t square. So t square is equal to 2000 divided by 10. So t is equal to root 200. This much time it will take for a bomb to reach the ground, that is to cover horizontal vertical distance. Now in this time, how much it will travel? Okay, so that distance, before that distance it should bomb. So x is equal to what? Vx into t. So this is actually 200 into time is 200. So okay, 200 into root 200 is the answer. So we can write like 200 into 100 into 2. So this will come out, we can write 2000 root 2. Okay, so this much distance before it should drop the bomb. That is the answer for this question. Okay students, so copy this. Okay, so this is about the different types of projectile. Okay, different types of projectile, the questions, how to approach, okay, certain examples. Okay, so study this well and practice more questions of this type. Okay, hi dear students, so in this session we are going to see projectile on an inclined plane. So the projectile, just like a parabolic projectile which we have studied, okay, what will be its time of flight, range, maximum height, all these things if we do that on an inclined plane. Okay, just like this. Okay, see, this is an inclined plane. Okay, let us take this angle as alpha. So if we project like this, okay, this angle is theta, we projected with the velocity u. Okay, so this is from bottom to top or from lower point to higher point. Okay, bottom to top of the inclined plane. This is also a possibility. Another possibility is, if this is the inclined plane, then the same projectile, but we will be projecting from top to bottom. Both are possible. Okay, this is alpha and this is theta. So how to deal this situation? This is what we are going to learn. Things are easy, just understand the concept. Okay, first we will see this. Then after getting everything, we will do slight changes so that we will get this case also. Okay, so right. So first I am going to write the time of flight formula for the general projectile. Okay, 2u sine theta by g. The maximum height is u square sine square theta divided by 2g. So in a normal projectile, when we are putting u like this, when this is theta, we resolve this initial velocity into u cos theta and u sin theta. So here this thing we can write in short as u of y component by g. You can write in this way, or in this one, y component square divided by g. Okay, like this also we can write 2g. This is the thing. Time of flight is actually 2 into y component of velocity by g, and maximum height is actually y component of velocity square divided by 2g. Okay, let it be there. Okay, now we will see this. So this is alpha, this is theta. Now as usual, we will in normal projectile, what we have done, we consider this as x-axis and we considered this as y-axis. Now whether we take this is x-axis, this is y-axis, this is a convention that we take in order to solve these kind of situations. On the other side of the globe, someone will be, or the other side, different sides of the globe on earth, people will be writing different x-axis and y-axis. Someone will be drawing x-axis, y-axis like this. Okay, different positions, so we will be drawing like that. So this is flexible, we can draw in whatever way it is convenient for us. So I am going to take this as x-axis and this one as y-axis. Okay, so this is y-axis, this is x-axis. Now I am going to resolve this u into u cos theta and this as u sin theta. Now always g will be acting downwards. Okay, so we will be marking g acting downwards. Okay, so g is towards the ground. So when we resolve that g, okay, if this is alpha, then this is also alpha. Whatever is the angle, that will come here, and we can mark this as g cos alpha. Its parallel component is g sin alpha. Right. Now if we need to find the time of flight, okay, if we need to find the time of flight, how we can find? See, at a maximum height, what is the y component of velocity at a maximum height? At a maximum height, y component of velocity here, y component is 0. Same way here also, it is not going further. So we can say that here also y component is what? 0. So if we use this equation, v is equal to u plus at, v is equal to u plus 8. So here when the particle reaches here, this is time of flight. Same way when the particle reaches the ground, it is time of flight. At a half of this, that is at a maximum height, capital T by 2 actually. So v is equal to 0, vy is equal to 0. We can write this as vy is equal to uy minus gy into t by 2. At a maximum height, vy is equal to uy minus gy into t by 2. Here it is 0, and uy is nothing but u sin theta minus, what is gy? Gy is, this is y, G cos alpha is acting in the minus direction, G cos alpha into T by 2. So bringing this to this side, we will be getting T is equal to 2u sin theta divided by G cos alpha. So this is what is the time of flight in the projectile in an inclined plane. The only difference that is going to come here, it is instead of G we will have to take G cos alpha. So here also u sin theta is nothing but the y component. So 2uy divided by gy. Actually this is also what? This is also gy, right? This is also gy. So that is what here. So time of flight is 2u sin theta divided by cos alpha. So this G cos alpha component we will have to add in time of flight. That is the only difference in time of flight. Is it clear? Note it down. Okay, done. Now time of flight is done. So I am erasing this. Okay, next thing, we need to find the maximum height. So maximum height is this height. This height is the maximum height. Okay, h max. Okay, so again we will use the equation v square is equal to u square plus 2as. So at maximum height, vy square is equal to uy square plus 2ay into the maximum height. This is actually 0. At maximum height, y component of velocity is 0. This is equal to uy is what? U square sine square theta. What is ay? G cos alpha minus 2 into G cos alpha into the maximum height. So this will come to this side. We can take like a maximum height is actually u square sine square theta divided by 2G cos alpha. Okay, so this is the formula for maximum height. What is the difference with the general projectile? Only here this G will become G cos alpha, no other difference. Okay, note it down. Okay children, so now we will see the range. Okay, okay, so in the case of range, in order to find range, okay, projectile, this is theta, projecting at an angle, sorry, this is alpha, it is projecting at an angle theta with the velocity u. Okay, this is what. Now what we will do, G is acting in the downward direction. Now we will resolve this. This is u cos theta and this is u sin theta. This is alpha, G cos alpha, and in this direction this is G sin alpha. Okay, now what is range? What is range? Range is this distance. This distance is what is range. This distance is what is range, correct? So that distance, range is actually what? This is x. This is in the x axis. This is x, this is y. Okay, so in the previous general projectile, okay, there was G which is exclusively acting in the y direction. There was no G in the x direction. But here in this case, G sin alpha is acting against the motion. g sin alpha is acting against the motion. So there is an acceleration in the x direction also. So in order to find this range, we will have to use which equation? S is equal to ut plus half at square. This we will have to find. Let us do. So range is equal to initial horizontal velocity into time of flight plus half into acceleration, the component of acceleration in the x direction, into the time of flight square. So range is equal to u cos theta into what is time of flight in the projectile. Just now we have derived. This is nothing but 2u sin theta, till this no change, divide by g. Okay, this is the time of flight. In addition to that, we will be putting a cos alpha here. The y component is cos alpha. Okay, minus half into this x is acting, the motion is in this direction, displacement is in this direction, sin alpha is acting in opposite direction, so we are putting minus. So g sin alpha into here 2u sin theta by g cos alpha square. Let us put 4u square sin square theta divide by g square cos square alpha. Is it visible? Is it visible? Yes. Okay, so this is what is range. So we will simplify. R is equal to g cos alpha, g square cos alpha. We will take the LCM. G square cos square alpha is the LCM. Here this is u cos theta into 2u sin theta. So we will have to multiply with the g square cos square alpha. 1 will be cancelled out. So g cos alpha minus half g sin alpha into 4u square sin square theta. So this is what now. So in this, see, this 2 u and sin theta, this is common here, correct or what? G is also common. We can take g u square, a 2 from this one, so 2 4 cancelled here 2, then from this sin square 1 sin theta we will take outside. You can see, look here, r is equal to 2u square sin theta, okay, 2u square sin theta, and divide by, so here all one g is there, here also one g is there, this will cancel with this square. So here we can write g cos square alpha, cos square alpha. This thing we will take outside, and here this will become sin theta came out, so cos theta cos alpha, okay, cos theta cos alpha. Here we will write in this way, cos alpha cos theta, and here what is available? Minus sin alpha sin theta is available. So this we can write as range R is equal to 2u square sin theta divided by g cos square alpha into cos alpha plus theta. Okay, so this is the formula for range. We need not by heart this. Okay, so this is the formula for range we are getting, but don't learn this, don't by heart this. Okay, we can do this problem, the problems associated with this much easily just by applying concept. This value we will be knowing, this time of flight we can find out, just by substituting we will be able to get the answers. So this is what is the range from bottom to top. Note it down. Okay, clear, done. So I am erasing. Okay, so here this is from bottom to top, bottom to top. So from top to bottom, the only difference that is going to come is r is equal to 2u square sin theta divided by g cos square alpha cos alpha minus theta. Only this is the difference that is going to come. Anyway, without using this formula we will be able to solve, so we are not worried about this. Okay, just you can note it down. Okay, now we will do some simple problems. Okay, we will do one problem. So a projectile is projected in an inclined plane. The inclined plane angle is 37 degree, projected at an angle 45 degree. The initial velocity is 10 root 2. So let us find time of flight, maximum height and range. So time of flight is equal to 2u sin theta divided by g. So this is equal to 2 into u is 10 root 2 into sin theta is sin 45. Divide by, here what will come, cos alpha will come. So divide by g is 10 into cos 37. So cos 37, we know if this is 37, this is going to be 3, this is 4, this is 5. Now we will substitute. So 10 root 2 sin 45 can be cancelled out. So this 10 can be cancelled out, and 2 divided by 4 into 5. So this is 10 by 4, 5 by 2 seconds. This is the time of flight, 5 by 2 seconds. Clear? Now we will see the maximum height. Maximum height is what? U square sin square theta divided by 2g, along with that cos alpha also will come. So substituting 10 root 2 the whole square, this will become 10 square into 2. 10 square into 2. So that is u square. Sin square 45 is 1 by root 2 all square, so 1 by 2. Divide by, here 2 into 10 into cos alpha is again 4, and here it is going to be 5. So simplify this, we will be getting the answer. So the answer for this question is 6.25 meter. This is the maximum height. Now we will find range. So for finding range, we are not going to use that formula. We will just apply the concept and we'll get the answer. So range is, suppose here G is acting in downward direction. So if you resolve, this is G cos alpha and this is G sin alpha. So here, since the acceleration is acting against the motion, okay, so let us use S is equal to ut plus half at square formula. So R is equal to u cos theta. So we need to resolve 10 root 2 into, here in this direction this is going to be u cos theta 10 root 2 into cos 45. So root 2 and cos 45 can be cancelled off. So here u cos theta into the time of flight plus half into the acceleration which is there in the x direction and t square. Making proper substitution, R is equal to u cos theta is 10, time of flight is 5 by 2 minus half into, so G sin alpha, G is 10, sin alpha is sin 45 into here 5 square by 2 square. So simplify this, we will be getting the answer. So the answer for this one is again 6.25 meter. Okay, maximum height and range both are same answers. Take this question, students. So here the inclined plane angle is 37 degree and angle of projection is 53 degree and the velocity is 10 meter per second. So pause the screen and solve yourself, then verify the answer. So time of flight is equal to 2u sine theta divided by g cos alpha, right? So just making the proper substitution, we will be getting the answer easily. Okay, so 2u sine theta divided by g cos alpha, 2 into 10 into sine 53. So here it is 37, 3, 4, 5 and this is 53. So 4 by 5 is sine 53. Okay, 4 divided by 5 and here we will have to substitute 10. Cos alpha is cos 37. Cos 37 is 4 by 5. So here this is 4 and 5 will go here. Okay, so 10 will be cancelled, 4 5 everything will be get cancelled. This is going to be 2 seconds. So time of flight is 2 seconds. Okay, so now we will see the maximum height. Maximum height is what? U square sine square theta divided by 2g cos alpha. So what is u square sine square theta? 10 square into sine square 53 is what? 4 by 5. So 4 square divided by 5 square into divide by 2 into g is 10 cos alpha, cos 37, 4 by 5, 4 and here it is 5. So 5 10 cancelled, then this 4 1 square is cancelled, then this 2 5 with the 10 can be cancelled. So this is going to be 4 meter. So this is the maximum height. That is the maximum height. Okay, next thing is range. So range is again u s is equal to ut plus half at square. So u cos theta into the time of flight minus half into g sine alpha into t square. So what is u cos alpha? This is 10 cos theta. Cos theta is cos 53. Cos 53 is 3 by 5 into the time of flight is how much? 2 minus half into 10 into sine alpha is sine 37, 3 by 5 into t square is how much? 2 square. Okay, so this is what? So this 2 and this one can be cancelled off. So 10 into 3 by 5 into 2, 10 into 3 by 5 into 2, both are same term. So range will be 0. Range will be 0. Clear? So range is 0. Hope you understood. So why range is 0? Why range is 0 means 37 plus 53, 37 plus 53, if we put, this is actually 90 degree. This is actually 90 degree, 53 plus 37 putting together. So they are projecting actually in this direction. Then it will come back to the origin itself. That is why range is equal to 0. Okay, note it down. Okay, now another possible question, this I am erasing. Another possible question can come from this is this maximum height. This maximum height is actually the maximum height from x-axis. This maximum height is actually from x-axis, that is we are considering this as x-axis. So this is what is the maximum height for what? For this maximum with this formula, that is with the formula h is equal to u square sine square theta divided by g cos alpha is for the maximum height from the x-axis or from the inclined plane. From the inclined plane, that this is a maximum height. But from origin, maximum height from origin, this is what actually, this is actually, if we project like this in the upward direction, in the vertical motion we have studied, that is nothing but u square divided by 2g. U square divided by 2g is the maximum height. So if we measure like this, maximum height from origin, this is equal to u square by 2g. How much? 10 square divided by 2 into 10. So 10 and square can be cancelled out. This is 5 meter. So vertical height from origin is 5 meter here. Vertical height from the origin is 5 meter here. So that is a possibility here in this type of question. Okay, students, take this another question. Okay, this is top to bottom. Till now we have seen bottom to top. Now this is top to bottom to top to bottom. Okay, so how to do this? So time of flight is equal to 2u sine theta divided by g cos alpha. So here u sine theta, g cos alpha, all these things doesn't have anything to do with the direction change, whether moving in this direction or this direction. This x plane, that is x axis, x line, in the x line, okay, suppose even if we take the x line like this or x like this, this u sin theta is also y component, g cos alpha is also y component. So nothing will happen to the time of flight in bottom to top or top to bottom. So t is equal to 2 into 10 into sin 53 divided by 10 into cos 37. Okay. So sin 53 is what? 37, 53, 3, 4, 5. So sin 37 is 3 by 5. Cos 37 is 4 by 5. Sin 53 is also 4 by 5. Cos 37 and 5 sin 53 can be cancelled like this, and this 10 can be cancelled like this, and this is going to be 2 seconds. Okay, time of flight is 2 seconds. Now let us take maximum height. So u square sin square theta divided by 2g cos alpha. So u square is 10 square and sin square 53 divided by 2 into 10 into cos 37. So 1 sin 53 and cos 37 can be cancelled. 10 and this square also can be cancelled. So 10 into sin 53 is what? 4 by 5. 4 by 5. Here this 2 is there. Okay, so this is 2. This is 2. 4 meters. So time maximum height is 4 meters. Let us find now range. So here range we need to be a little bit careful. That's it. Nothing to worry. Okay. So a range is equal to, which formula will be using? X is equal to ut plus half at square we are going to use. So if this is u, this is u. So this is going to be u cos 53. If this is g, then perpendicular component, this is alpha, this is going to be g sin alpha. Here this is g cos alpha. So this g sin alpha is aiding the motion. Acceleration direction, movement direction are same. Both are same. So u cos 53 into t plus half into, this is ax into t square. So range is equal to 10 into cos 53 is how much? 3 by 5 into time of flight is 2 seconds. Where it is? We found 2 seconds, right? Plus 1 by 2 into, this is g cos alpha. So 10 into cos 37. Cos 37 into 2 square. So simplify this. We will be getting the answer. This is not cos, this is sin. Sin 37. Substitution is correct, right? 10 into cos 53 into 2. Okay, so everything is fine. So the range we will be getting the answer as 24 meter. 24 meters. Okay students, so hope you have noted down. So this is the introduction of projectile in an inclined plane. Now we have to study a bit more details from this same topic, like a maximum projectile for which angle. All these things we will see in the next session. So meanwhile, just understand the concept, just understand the problems and all. Okay, one more session we will have to spend on this. Okay students, thank you, bye bye, good luck.